Welcome to Subatomic Tanvi.
Hi, everyone. But today, before we begin, here's some interesting news for you. Recently, I joined Girls in Quantum as the ambassador of New York and New Jersey. So, Girls in Quantum is a youth led nonprofit organization empowering girls and women. And Girls in Quantum seeks to democratize quantum computing and emerging tech education among students. Girls in Quantum has already impacted over 5,000 students from 26 different countries. Do check out our website, girlsinquantum.com. Now, let's get back to our episode.
And I have no idea what we're going to talk about today.
Well, that's an error in the system of your brain. That's what we're talking about today.
Wait, we are going to talk about my brain?
No, of course not. We're going to talk about quantum errors.
Oh, that makes a lot of sense. I know exactly what those are. So, what are they?
Quantum errors are things that go wrong in a quantum computer.
Go wrong? Why do they go wrong?
Because qubits are highly sensitive to their environment, so just one tiny variation can cause the calculations to be completely off.
Okay, got it. So, how do these errors happen in a quantum computer?
So there are three types of quantum errors: bit flips, phase flips, and bit phase flips. So bit flips change a qubit's state, phase flips change a qubit's orientation, and bit phase flips do both.
Okay, so how can we correct these errors?
So bit flips can be corrected using a repetition code, which is when a logical qubit is transformed a specific into a specific state. And phase flip errors can be corrected using a phase flip code, which is when logical qubits are transformed into a specific state using regular qubits in a way that can be detected. And bit phase flips are both simultaneously.
So you mentioned regular qubit and a logical qubit. What's the difference between a regular qubit and a logical qubit?
So a regular qubit is just, well, a regular qubit that's used in quantum computers. But a logical qubit is a qubit that's made of qubits.
So can you simplify these errors and the process to correct them a little more in a simple way? My brain is about to break into half. There's like too much information to understand.
Okay, let's do it. So imagine you're writing a secret message. A bit flip error would be if the ink on your secret message smudges a little. A phase flip error would be you changing the color of the light that's used to decode the message. And a bit phase flip error would be both.
Got it. So how do we correct them using the in the secret message example that you just mentioned?
So to correct a bit flip error, which is the ink smudging a little, we could make multiple copies of the same exact secret message and compare the smudged one to other ones to see exactly where the error is, where exactly the ink is smudged. To correct a phase flip error, we could use a light filter to filter out the decoding light and see which light is suitable to decode the message. And again, bit phase flip errors, to correct them, we do both.
Okay, that is so much better. My brain is now overflowing with wisdom.
So is mine, but I love the feeling, don't you?
Absolutely. Thanks for another awesome episode, Subatomic Tanvi.
You're welcome. Bye, everyone.